In this problem, we're told that adult male pulse rates are normally distributed with a mean value of 69.58 beats per minute and a standard deviation of 11.33 beats per minute. So I typically tell my students that anytime that you're working on a problem and you're told that the random variable is normally distributed or your data is normally distributed, just make a sketch of a bell-shaped curve on your scratch paper. I also like to write down the mean value and the standard deviation using the correct notation, mu and sigma, so that I know what numbers I have to work with. And then go ahead and label the mean value at the center of your distribution because that's where we find the mean value. It's always at the center of that bell-shaped curve. Okay, question A says, find the pulse rate separating the lowest 2.5% and then find the pulse rate separating the highest 2.5%. So our goal is to ultimately find the pulse rate. So I'm going to call the pulse rate that separates the lowest 2.5%. Let's call that x sub 1. So right now we don't know what that pulse rate is, but we're going to find it. And then the pulse rate that separates the top 2.5%, let's call that x sub 2. So again, don't know what that is yet, but we're going to find it. And then now I'm going to mark where x sub 1 and x sub 2 would be on this bell-shaped curve. So the pulse rate that separates the bottom 2.5% is going to be on the left tail, so x sub 1 is going to be somewhere there. And then x sub 2 is going to be symmetrical, but it's going to be on the right tail, so I just mark x sub 2 there. And I'm also going to shade in the area that represents 2.5%. So again, my drawing is not to scale, but if it were beautiful and to scale, then the area that I'm shading on the left would match up with the area that I'm shading on the right. But you guys get the idea. So I'm going to go ahead and label this area, but I'm going to convert that percent to a decimal to show the area that is given in this problem. So this is a problem where you know the area under the curve and you're trying to work backwards to find the unknown value, which is x sub 1. And then again, we're going to repeat the process for x sub 2. So there are two ways to find these pulse rates. You can either use z-scores and table A2, which I have a screenshot here, and then, or you can use the graphing calculator. So I'm going to show you both methods first using z-scores. So if you recall the formula for calculating a z-score, that's z is equal to x minus mu over sigma, but we can modify this formula and solve it for x. So if we solve it for x, then that formula is x is equal to your z-score times your standard deviation plus the mean value. And it's a good idea to just memorize this formula as well, okay? So if I want to calculate x sub 1, I need to first figure out what the z-score is for x sub 1. So I'm going to write it below here. What's the z-score that corresponds to a pulse rate that is located on the left of this bell-shaped curve? So we're going to go to the negative z scores on your table. So go to the negative side because we're looking for a z-score that's on the left tail. And you're going to search the body. So you're going to search the body of the table and search for a decimal that represents 0.025. So the body of the table gives us the area. And hopefully you can follow where I'm circling here on the table. I see an area of 0.025 and it corresponds to a z-score of negative 1.96. So that gives me a z-score. I'm going to mark it down on the distribution below here of negative 1.96. And because the pulse rate that separates the top 2.5% is symmetrical to the left side, that means that I don't need to go to the positive side of the z table, but you can just to confirm it. But it's just going to be the positive value of 1.96. Okay, so that's going to be the z-score for x sub 2. So now that we have the z-scores, let's go and plug it into this formula here and solve for those pulse rates. So let's go ahead and do that for x sub 1. The z-score is negative 1.96. Standard deviation is 11.33. Mean value is 69.58. Put it into your calculator. That gives us a pulse rate of 47.37 beats per minute, which is the pulse rate that separates the bottom 2.5%. Now let's calculate x sub 2, but we're going to use that positive z-score of positive 1.96. So multiply it times the standard deviation and then add the mean. This gives us a pulse rate on the right tail of 91.79 beats per minute. So the pulse rate that separates the top 2.5% is 91.79 beats per minute. So that's how you would use z-scores in the z-table. Now, if you want to use your graphing calculator, follow along with me on the right-hand side here. I've got a screenshot. So on your TI, oops, let me get my marker here, TI 84 calculator, you're going to press the second button and then click on VARs, which is going to take you to your distributions. And then you're going to choose inverse norm. So inverse norm is the function that you use when you know the area. So to find x sub 1, so I'll make a little note here. To find x sub 1, you're going to use inverse norm, and notice that we already know the area to the left is 0.025. So you just type in the area to the left, then you type in the mean value, which is 69.58, and the standard deviation, and then press enter. And that is going to give us 47.37 as well. Now, if you have one of the newer calculators, it's pretty fancy. It gives you the option to choose left, center, or right. So if that's the case, then you can choose the area that's being shaded. So whatever area you put into that first line there, you can choose if the area that you're typing in is the left, the center, or the right. Now, if you have one of the older calculators, it does not have this fancy function. It automatically defaults to the area to the left. So please be mindful that if you have one of the older calculators, it always defaults to the left. Now, it's important to remember that because when you get to the second part where we're searching for x sub 2, if you have one of the older calculators, when you use inverse norm, you have to remember to type in the area to the left. So I'm going to use blue here on the bell-shaped curve, right? To find x sub 2, the area to the left of x sub 2 is everything that I'm shading in blue here. So notice that the area to the right of x sub 2 is 0.025, and the area to the left is what's in blue. So we know that the total area under the curve is 1. So to get the area that's in blue, the area to the left, I have to take 1 and subtract that red area on the right. So that is what you would type into your calculator, 1 minus the area that is on the right, which will give you the area on the left, right? So area on the left. And then again, type in the mean and the standard deviation value, press enter, and it'll give you 91.79, which are the same answers that we got when we used the formula in table A2. So you choose which method you like and stick with it.